All right, let's we're going to talk about the sixth section of chapter 1, which is some other polynomials, other types of equations. So, things we're going to learn. We're going to solve polynomial equations of a degree 3 or higher. Equations involving radicals, which is going to be fun. And also fractions or absolute values. We'll throw those in there as well. Okay? Hopefully we'll apply both of these as well. Okay, so first of all, polynomial equation. We had polynomial up here. Don't worry about this. This is what the notation the book has for a polynomial. Equation. The only thing that's different about our polynomials before, we didn't have it equal to a number. So don't be scared by this. If you want, you can read this and understand that a sub n is just the first coefficient, raised to the nth power, n is the degree of the polynomial. It goes down by 1 each time to be written in standard form. Okay? Don't worry too much about that. But these are the types of problems you will have to worry about, which is solving a polynomial equation like this. Okay? Now, some of you guys are going to be tempted when you're solving this to divide both sides by x squared. Okay, be careful not to do that. Because when you divide by x squared, you're getting rid of some of these x values, and you're actually going to be getting rid of some of the solutions. This is a fourth degree polynomial, which there are potentially 4 zeros. So don't get rid of some of them. What I want you to do is subtract both sides by 48x squared. So you're going to have 3x to the fourth minus 48x squared equals 0. Now obviously you could graph this and find out where the intercepts are. But let's do it algebraically. So we're going to pull out a 3. If we pull out a 3, we're going to pull out an x squared. We have left over x squared minus 16 equals 0. And now we can factor this, because this is a difference of two squares, and it factors in x minus 4, x plus 4. And now we can see we have 3 places where this fourth degree polynomial touches the x-axis. We got x equals 0, we have x equals 4, we have x equals negative 4. So now these are our solutions to this. Let's double check that all of them work. Obviously 0 works. 4 would be, let's check to see if that works real quick. We know this one checks. But this one 4 will give me on the left side 678. On the right side, 4 squared is 16 times 48 is 768. So the middle one checks. And the last one, negative 4, that's going to check as well, because the negative goes positive when it's an even power on both sides. So it's going to give me 768 equals 768. So all 3 of them check. Now, you could graph this if you wanted to. Like I said, graph the left and the right. But what you're going to see is a fourth degree polynomial basically looks like a parabola for the most part. But I know that it touches at 0. It's got a multiplicity of 2, so at 0 it touches there. It doesn't change signs. And it also touches at negative 4 and 4, so it's going to look like this. It goes down, it changes signs at negative 4, and then it doesn't change signs here, and then it goes back up. So that's what this, if you were to graph this in your calculator and find out where it equals 0, you'd have to find these 3 zeros. This one, and this one. By doing second calculate 0. But this is the work I'm going to expect to see in a quiz or a test, especially a no calculator part, obviously. So don't rely on your calculator too much. If you were to graph this in your calculator, just plug it in. It does look like what we thought it would, which touches in the spots that we thought it would. So you can always, with your calculator, do the second calculate 0, and go to the left of the intersection point, hit enter. Go to the right of the intersection point, hit enter for the 3rd time, and it gives you these zeros, which that one, for some reason it's saying no sign change, but we can look at that. We know that it does have a 0 at 0. We're also going to solve equations involving radicals, so you're going to have things like this. There's different ways to do this, but the easiest way to do this is to add x to both sides, and then square both sides. So you're going to have the square root of 2x plus 7 equals 2 plus x, or I'm going to write it as x plus 2. And now I'm going to square both sides. Now when you square both sides, don't forget that you need to put this in parentheses and FOIL. Okay? So this becomes 2x plus 7 equals x squared plus 4x plus 4, when you FOIL it all out. Okay, now I just put it in standard form and solve. So I'm going to subtract 2x from both sides and subtract 7. And this gives me 0 equals x squared plus 2x minus 3. And I'm going to see if this FOILs. You can use quadratic form. I'm sorry, factors. You use quadratic formula. You could graph it. Yeah, let me just see if x times x. Let's see. Minus 1 plus 3 factors into. So yeah, the solutions are x equals 1 and x equals negative 3. We should check those to make sure that they both work and they're not extraneous. So let me do that real quick. All right, if you check both of these, the first one works. You get 2 equals 2. The second one does not work. So the second one is extraneous. Okay, now this one's going to be even more difficult. So let me move this over where we can get more room. These are going to be the hardest problems from the homework, doing things like these. We want to solve this. Obviously, we're going to need to square both sides. But first, I'm going to add to both sides the square root of x minus 3. So I added this to both sides. This gives me the square root of 2x minus 5 equals 1 plus the square root of x minus 3. Now I'm going to have to square both sides. Don't forget when you square both sides, you have to square this as a quantity. So this turns into 2x minus 5 equals 1 plus 2 of these in the middle, because they're going to add together, right, first when you FOIL this out. I know I'm going fast through the FOILing, but I'm assuming you guys can FOIL now. And then last times last is going to be x minus 3. And I don't need the parentheses there. Okay, so the common mistake students make is that they want to just square this and square this. You can't do that. That's not a property. When you have x plus 5, you can't just squared. You can't just make that x squared plus 25. That's not true. You have to FOIL this. Same thing with this up here. This is x plus 5. No different. You have to FOIL it.
Wait.
All right, so now I'm going to simplify. I'm going to subtract x from both sides. I'm going to take the negative 3 and the 1 and make negative 2. Then I'm going to add 2 to both sides. That gives me x minus 3 equals 2 times the square root of x minus 3. So I simplified, and now it's just like the last problem we just did. We're going to need to square both sides again. Okay? But it's exactly the same as the last problem. It's x squared minus 6x plus 9 equals 4 times x minus 3. All right? And then obviously you FOIL, or I mean distribute, and get it in standard form. So now I'm going to subtract 4x from both sides. This gives me x squared minus 10x, and then add 12 to both sides. And this gives me 21 equals 0. And now we just need to solve this quadratic for when it intercepts the x-axis. So let's see if x minus 7, x minus 3, it factors 2. So the solutions are x equals 7 and x equals 3. Don't forget to check both of these to make sure they're not extraneous. All right, so I want to check both of these back up in the original equation way back at the top. So 7 and 3. All right, so 7 would be, this would be 14 minus 5 is 9, square root of 9 is 3, minus 7 minus 3 is 4, square root of 4 is 2, equals, let's see, that does equal 1. So that checks. So 7 does work. All right, the other solution 3, let's check and see if that works. 3 times 2 is 6, minus 1 is square root of 1, which is 1, minus 0, and that does equal 1. So both of them work. Okay, both of them check. All right, we're also going to be solving problems like this again, which this is a rational equation. And how we want to solve these, the easiest way is to clear fractions. Okay, again, anytime we have fractions and an equal sign, we want to clear fractions. So to do that, we're going to multiply through by the least common denominator, which in this case is x times x minus 2. Because that's one obviously goes into that, one goes into everything. X goes into it, and so does x minus 2. So to do that, that'll clear fractions. So we'll multiply the top by this. Now, x cancels here, so I end up with 2 times this quantity, x minus 2. X minus 2's cancel here, I end up with 3x. And then, I end up with 3x. And then minus x times x minus 2. Don't need the 1. All right, and then it's just a matter of solving this quadratic now. Get it in standard form, so distribute the 2 to both terms. Minus 4 equals 3x minus x squared plus 2x if you distribute the negative x to both of these. Now to get it in standard form, I'm going to add the 2x and 3x to get 5x. So I'm going to put the negative x squared first on the right side here. And then I'm going to subtract 2x from both sides and add 4 to both sides. Okay? So this would give me 0 equals negative x squared plus 3x plus 4. And then you can try to FOIL this. I'm not sure if it does FOIL. I'm going to multiply through by a negative 1. You can do that. It's going to change these signs. Then I'm going to try to factor, if I can, x and negative 4 and positive 1. Yes, it does factor, which is nice. We don't have to use the quadratic formula or the calculator then. So this would be x equals 4 and x equals negative 1 for our solutions. Make sure we check those into the original equation, make sure they both work and when they're radius. I'll do that real quick independently. Yeah, they both work. When you try 4, you're going to end up with 1/2 equals 1/2. And when you try negative 1, you end up with negative 2 equals negative 2. So they are both solutions. Okay, last